You leave Earth in an instant, and before you blink, you're orbiting another star. This isn't science fiction anymore. This is the warp drive. The same technology we saw in That's Star Trek for our global friends is now dazzling physicists at NASA. But how can you travel faster than light without breaking the laws of physics? Imagine boarding a spaceship, sipping your coffee, and reaching a star on the other side of the galaxy before it gets cold. Sounds impossible, right? Well, scientists are working on a mind-bending idea that could outrun light itself. Let's start with a simple truth. Light is the fastest thing in the universe. When you flip on a light in your dark room, it fills the space in an instant. Because light travels in a vacuum at a staggering 299,792,458 meters per second. That's about 300,000 kilometers in a single second. That's so fast, you could circle Earth 7.5 times in 1 second. But even this king of speed falls short in the vastness of the cosmos. The universe is like an endless ocean, with distant stars like islands that light takes years to reach. Take Proxima Centauri, the closest star to our solar system. It's 4.24 light-years away. That means the light we see from it today left 4 years ago. If we tried to get there with today's tech, like a spaceship cruising at 70,000 kilometers per hour, it would take about 65,000 years. A bit discouraging, isn't it? That's where scientists dreamed up a revolutionary solution: the warp drive. You might have heard of warp drives and where spaceships zip across the galaxy in a flash. But believe it or not, this isn't just fiction. The idea of warp drives didn't start with NASA. It began in the imagination of sci-fi writers. From Jules Verne's Wild Tales to Star Trek's iconic warp engines, humanity dreamed of bending space. But it wasn't until 1994 that Miguel Alcubierre turned this dream into a math equation. Later, in 2003, Gerald Cleaver refined it, showing how negative energy might work. In 1994, Miguel Alcubierre shook the world with a paper saying, "We can't move faster than light, but we can move space itself." Picture the universe as a giant, stretchy fabric with stars and planets scattered across it. According to Einstein's general relativity, anything with mass, like a heavy ball, bends this fabric. Now, what does a warp drive do? It scrunches the fabric in front of the spaceship and stretches it behind like folding a rug in half. The ship sits in a bubble of space-time, not moving itself, but letting space move around it. The result? Travel faster than light, without breaking Einstein's rules. You might be thinking, wait, didn't Einstein say nothing can go faster than light? Exactly. According to special relativity, no object or information can exceed light speed in normal space. But the warp drive cheats. Instead of moving the ship through space, it manipulates space itself. It's like redirecting a river to carry you to your destination instead of swimming. This way, you're not breaking Einstein's rules. you're using them to your advantage. Warp drive isn't an ordinary engine that pushes a spacecraft forward with thrust or propulsion. Instead, its core idea is to change space itself. Imagine rolling up a carpet so that the end of it comes closer to you. That's how the spacecraft gets closer to its destination, not by speeding through space, but by reshaping it. In this model, space in front of the spacecraft contracts and space behind it expands. This creates a warp bubble in which the spacecraft remains stationary, while the bubble itself moves by distorting space around it. Theoretically, this method could allow the spacecraft to travel faster than light, not by breaking the laws of physics, but by bending around them. To create this magical space-time bubble, we need something really special: negative energy. This is a strange kind of matter that works the opposite of normal matter. Regular matter creates gravity and bends space, but exotic matter expands it. Alcubierre showed that if we could wrap a ship in a bubble of negative energy, we could compress space in front and expand it behind. The ship would ride a cosmic wave to its destination. But here's the catch: negative energy only exists in theory. Even if we could make negative energy, we'd need a huge amount. Like the mass energy equivalent of an entire planet. That's a big hurdle. But don't lose hope. Scientists are working on it. In 2021, a physicist named Erik Lentz published a paper that got everyone excited again. He proposed we could create a warp bubble using more ordinary energy, like solar plasma, with much less negative energy. His calculations suggest that controlling energy equivalent to a few hundred kilograms of matter could make a warp drive possible. That's still a lot, but it's way less than a planet's worth. Lentz and his NASA team are exploring quantum physics and effects like the Casimir effect, a weird phenomenon where two metal plates placed nanometers apart create quantum vacuum fluctuations. It's still theoretical, but every step brings us closer to interstellar dreams. Imagine if warp drives become real. Instead of 65,000 years, we could reach Proxima Centauri in days or even hours. Habitable planets found by the Kepler telescope wouldn't just be dots in the sky, they could be humanity's next home. Warp drives aren't just about travel. They could transform our understanding of physics. If we can manipulate space-time, we might unlock new ways to generate energy, communicate across stars, or even build time machines. Yes, time machines, because when you bend space-time, time gets playful too. We've got a long road ahead. Producing negative energy is still a huge mystery. Even if we solve that, controlling it is another beast. Imagine keeping a space-time bubble stable around a ship. One tiny mistake could destroy everything. Plus, some scientists worry warp drives might create dangerous gravitational waves, or even tiny black holes. Right now, NASA's EagleWorks team is testing tiny warp models. They use computer simulations to see if space can bend. In 2023, they reported small-scale successes, but the big hurdle? We still can't make negative energy. Every test is a leap toward reality. Despite the challenges, scientists aren't giving up. NASA's Advanced Propulsion Project is pouring big money into ideas like warp drives. Labs like the Jet Propulsion Laboratory are building mathematical models and computer simulations. Even if it takes 100 years, every step is a scientific revolution. One day, our kids, or their kids, might board warp-driven ships and visit stars we only dream of today. Picture sitting in a space cafe on Proxima Centauri, sipping alien-grown coffee and looking back at Earth, just a tiny speck in the sky. That day, humanity's science will have reached heights even Einstein couldn't. So, what's your take? Could warp drives become reality? Are we on the verge of a cosmic leap? Drop your thoughts in the comments below.